Hi, I'd like to welcome you all to the Exafamine Data Publishing Workflow with FAIR Modules webinar. This webinar is presented to you by me, Smaran Chaudhary, and my colleague Martin Schumann from the Leibniz Supercomputing Center in Germany. The Exafamine project is a project to leverage supercomputing facilities of extreme data analytics workflows by providing an open platform of flexibly deployable modules. To this end, we introduce the FAIR objectives that we set out to reach with this project. The FAIR modules we are going to present today aims to provide an end-to-end workflow in compliance with FAIR principles. We present a streamlined workflow which focuses on a data store module that works as an ETL pipeline to handle the metadata. Second, a FAIR data subsetting API that provides a simple fetching of subsets of data from different data sources. Finally, publishing of this metadata to different FAIR data catalogs like the EU.DATS, B2Share, or a self-hosted Invenio RDM-based platform in Exafamine flavor. Before we dive deeper into the publishing workflow, we will look at the Exafamine architecture. The Exafamine complete architecture is presented here. It covers the modules and submodules and the capabilities of the projects for extreme data analytics using the supercomputing tools, including the ArcGIS library, also known as the Advanced Querying Indexing System library. On the left hand side of the architecture, the toolboxes module can be used with the ArcGIS library. Under it is the data layer, which consists of object stores and database management systems. These can be deployed using the instantiation recipes provided by us. For compute orchestration across European systems, you can see on the right side of the architecture, we use the Lexis platform in the scheme. Finally, the part we are going to focus on today is the data connectivity and FAIR support module. The dataset connectivity and FAIR support submodule provides data publishing workflows with a special care for FAIR compliance. On the left side, we build up on the dataset index and portal module, which provides the catalog for FAIR data while assigning unique PIDs to the dataset. These catalogs are built on top of modules that provide both sides of the workflow, publishing through our data store toolbox and access to the datasets using the FAIR subsetting API. We will cover this in the later parts of this video. First, we'll discuss what exactly is FAIR. The concept of FAIR was given by Wilkinson et al. In 2016, providing a clear guiding principle for handling scientific data. In the interest of time, I would like to make a note here that we are only presenting a subset of the FAIR principles. For the detailed description, please refer to the original paper. So, the F in FAIR stands for Findable, which says that the data should be described with rich standardized metadata and assigned a globally unique persistent identifier and should be also indexed in a searchable resource to enable reliable and efficient discovery. The A in FAIR stands for accessibility. The accessibility means that the humans and machines, however restricted the data is, should be able to access the data through standard protocols such as APIs or common file formats like JSON or YAML. The third part is interoperable, which says that the data you should use common language and vocabularies to allow integration with other data application or workflows. And the final part is reusability, which says that the data should be properly documented and released under open licenses to facilitate further research and development. So now we'll start describing the tools that we discussed. And then after a little bit of introduction, then we can move on to the demos for each of the tools. So first we will start with the data store. So data store is essentially a extract, transform and load pipeline for extracting data from the data sources and transforming it into a end system metadata mapping and then uploading it or publishing it to the data catalog. We support the end systems like EU.DATS, B2Share, or Invenio-based RDM systems, as we discussed before. The data store works as a command line tool and it is used to publish bulk metadata, which can be parsed through the local files in the file system, or it can be parsed through index-based systems such as OpenSearch or Elasticsearch and other such indexes. And then the second part of our FAIR module is the FAIR data subsetting API. The FAIR data subsetting API aims to define and provide FAIR data products from object stores and database management systems. Definition of these data products are done by generating the UUID and mapping them to the query systems to allow access to the subsets of the data. The API supports multiple backend systems as shown here in the list. Some of these include the Postgres, SQL, MongoDB, vector-based systems like Milvus, and object stores like Minayo. The API allows us to create these UUIDs through simple GUI. These UUID can then be used inside the URLs published with the metadata of the subsetted data to allow users to download this chunk of the database using the FAIR data subsetting API. Another important factor that API takes into account is the security, where highly sensitive database credentials are stored in a secret manager service called InPhysical. This provides a better management and access to the secrets. Finally, now I present to you the complete verification pipeline that we have been building up to. So, as you can see in this diagram, on the right, we present the data store that collects the metadata and publishes them to the FAIR data portal. While on the left, the FAIR data subsetting API provides a direct access to the data linked to this metadata in different storage backends. And of course, all this is through this secrets manager called InPhysical, which provides a hardened security layer for the data publisher. And now I will hand over the mic to my colleague Martin Schumann, who will take you through all of these tools and how to set them up and how to use them with insightful demos for the verification workflow.
Thank you, Smaran, for that introduction. We come now to InPhysical, a system that provides secure storage of credentials. When we look at our overview again, the InPhysical Secrets Manager stores the access controls to the various data stores, such as Postgres, MongoDB, and S3. It also controls the access to be able to create new subset queries. So, a little overview of InPhysical. It is an open source end-to-end encrypted platform which is designed for centralized management of application secrets. What this means for us is that for the subsetting API, no credentials are saved locally, only the virtual path to where they are stored in InPhysical. They are only retrieved when needed at runtime and not ever stored inside the API library itself. We use an .environment file for configuration. To access the credentials for the subsetting API to use, we utilize access tokens which are able to use the saved credentials from InPhysical to connect to the data stores. These tokens can be automatically rotated in regular intervals and also revoked. They also have a built-in expiration time. Now we come to the demo, where I will show how to set up an InPhysical system. Setting up an InPhysical instance is straightforward, as the InPhysical developers provide a Docker Compose file with all of the required components. First, we download the Compose file. I'm downloading it in the same folder as the FAIR API repo, but this is not required. Next, we need a .environment file with a few values. These values are just illustrative. Please use your own secure credentials. I'm copying the example values into the actual .environment file. Then we start the Docker containers with Compose and wait for them to be ready. This will take a while, so we can fast forward through it. When they are ready, we can go to the browser to finish setting up InPhysical. Now we are in the browser, where we first set up a so-called super admin account, which administers the InPhysical secret stores. Here I'm creating an example one for me. After that, we have to manage some general settings. I disable user signups so that I can only add people manually, and I set the default organization. Then just click Save and we can go back to the organization for the next steps. We now need to add some credentials. To do this, we first need to create a new project. We give it a name and make sure the project type is Secrets Management. For the FAIR API, we need an admin account. This account is the only account which is allowed to create new UUID mappings. To create this account, we first add a new secret for the admin username. Then we add the admin password. I just let InPhysical generate one for demonstration purposes, but you can also enter one manually. This step is crucial as the subsetting FAIR API requires these secrets to be set in order to function. After we have created the FAIR API access credentials, we will now add some data store access credentials. In this case, Postgres. First, we enter the username, then we enter the password, which I have randomly generated for this demonstration. To actually use these credentials with the FAIR API, we need two more pieces of information. The first is a project ID where the secrets are kept, which can be found in the URL. The other is a service token, which allows the FAIR API to access the secrets we created earlier. To create the service token, we go to Access Control, Service Tokens, and create a new token. We give that token a name, for example, FAIR API. Each secret can be given a scoped environment such as development, staging, and production. You can also set an expiration date. Read permissions are sufficient for this token. Then copy the service token that was generated and save it somewhere secure, as this token is only shown once. In the next demo, we will show where to use the project ID and service token. Now that we have set up in physical, we install the FAIR Data Subsetting API. For this, we have to install a backend, the web server. When we take a look at the overview diagram again, we install in physical, and now we have the FAIR Data Subsetting API, which connects to physical and the data stores. It can query data which it provides to the research data catalog/portals. Now for a quick look at the technologies of the FAIR Data API. It requires an SQLite database where the mapping between UUIDs and queries are stored. This database contains information about how to retrieve data from the data stores. Of course, we have the UUID. Then we have the data source hostname or IP address and port. Then the path in physical, where the access credentials are stored. The type of target system, for example Postgres or S3 or iRods. Then the target system information, such as the database name or bucket location in the case of S3. And then the actual query to perform, for example SQL or the path if the data store is S3. We also use Fast API and a UWSGI web server, which provides an API with open API documentation, which can be viewed under the /docs endpoint. We also provide a simple HTML GUI which uses the API under the hood. And then of course the physical system to fetch credentials using an access token. And now I will show you how to set up the FAIR API. To install the FAIR Data Subsetting API, there are two main steps. The exact commands to execute can also be found in the repo's README. The first step is to create an SQLite database which stores the UUID to query mapping. To do this, create a new database with the name internal metadata.db in the root folder of the repo. Then create a new table with the SQL query shown on screen, which can also be found in the README. Then you just exit out of SQLite. In the second step, we need the service token and project ID from physical, which we got in the earlier demo, and enter it into the .environment file inside the utils folder. Now we can also install the backend and web server. First, we create a new virtual environment and activate it. Then we install the packages. Again, we will fast forward to the install process. And when the process is done, we start the API server using UVcorn. As you can see here, we also get the local URL where the server is running. We will use this in the next demo. Now that we have installed the FAIR backend, I will show you one way to use it. As you can see in the overview, we are still in the same area where we have the FAIR Data Subsetting API. For the usage, the FAIR API has three endpoints. The normal download, which will download results from the database queries as JSON. Then we also have download_file, which downloads normal files, for example files stored on S3 or OpenSearch. And the create mapping, which allows an admin or the FAIR database owner to create a new UUID mapping. The API endpoints can also be viewed and tested at the /docs endpoint, which is a standard open API system. We also provide a lightweight GUI to download files or create new mappings. And now I will show you how to use the FAIR API using the GUI. Now that we have everything set up, I will now show you how to create a new UUID mapping in the GUI. Later, Smaran will also show how to use the API endpoints directly. To create a new mapping, I'll provide information about the data store where I want the query to run. First, I add the server URL with its port. Then I enter the path in physical where the access credentials of the data store are saved. Next, the type of data store, here Postgres. Then the data store name, which in our case is the name of the database itself. Then I enter the query. As mentioned before, only an authorized user can create a new mapping, so I now enter the credentials I created in physical earlier. And now a new mapping has been created. I can copy the UUID for later use, or also use the download buttons to download the results of the query. And now back over to Smaran to bring it all together.
Great. So now after these insightful walkthroughs, I will now try to bring it all together and show you how the complete pipeline can be utilized for researchers, making it easier for publishing data and providing access to the custom data subsets through the metadata portal. I have cloned the data store repo from our GitLab repo instance and set up the virtual environment as described in our documentation. You can see I have already switched to this environment, and now I can just run the data store command to publish it on the training portal. I would first like to make a note that the metadata that we use today is a fictional data that we are just using for testing purposes. This metadata folder was not in the GitLab repo and was created just for this demo. In the real world scenario, there should be a metadata that you are ready to publish or create a draft on the instance for B2Share or the Invenio portal. So after this, we will move on how we can then directly use the data store to create a draft in our B2Share instance. So you paste this command, you can see all the details in the documentation of the data store. It's basically just you giving the host, the authorization token, the the metadata file name style, and the super metadata file which contains the important information that goes with every data set. So after I press enter, it will start giving me these small unverified HTTPS error warnings, but these are not necessary in our scenario because we are using a training instance. So we can ignore these for now, and then we move on to our instance. So here we are on our training instance of the B2Share. Now, if I go into my dashboard and I can see the exact data set that I pushed from the data store. And it has all the metadata. And if we, this is just currently a draft. So if I just want to see how the published data set will look when it's published on the website, it will be something like this. And the record will have the title, all the metadata mentioned here. And of course, it also allows you to export the metadata in different formats for later use. And what you see here is our dataset link from the Fair Data Subsetting API, which can be used to download the data directly listed for this metadata. So if I click on this, here we go. We have the downloaded metadata. And if I open it, and this is the downloaded file, and we have all the metadata downloaded. And yeah, so this is basically it, and we complete our Fair Data publishing workflow. And then we saw how easy it is to publish data going from the data store to publishing on the Fair Data portal here, for example, the B2Share portal, and using the Fair Data subsetting API to finally download that data to your local computer. So after looking at this complete workflow for the Fair Data publishing pipeline, we will now look at the last part of this webinar. In this last part, I would like to introduce you to our Fair Data Invenio RDM based portal. This Invenio RDM based custom portal is provided to help the users that want to self host a metadata portal or a catalog. This is provided as an alternative to the B2Share portal that we just saw in the last demo. The recipe for this instance is, of course, provided in our recipe catalog on GitLab. Just to give you a quick overview, the data portal provides a self-hostable solution like the B2Share in the sense that it can be hosted on your on-premise servers so that you have complete control over the data. So as we see here, the Fair Data portal sits right in the middle of our architecture that we saw earlier. On one side, the data store pushes the metadata, and on the other side, the Fair Data subsetting API fetches data from heterogeneous data backends. The Fair Data portal is provided as an alternative to the B2 share, so the users have a complete control over their data and where it's published. And of course, the recipes are provided by us. Another part is that a PID is automatically assigned on these systems, and in terms of Invenio RDM, a digital object identifier or a DOI, which is well recognized in the scientific community. This data, of course, can be retrieved using our API, completing our end-to-end approach for provisioning fair, compliant data. And in the next part, I will show you how the portal looks and give you a little bit of walkthrough how it works. So now we're going to take a look at the Fair Data portal in the Exafamine flavor that we provide recipes for. So here is our portal, and as you can see, it has a front page and a nice view of all the published metadata files that are on the portal. You can see it elaborates everything. And if we open up one of these records, we can see the authors, we can see the abstract, table of contents, and all the data that is provided in the metadata. The metadata can also be exported out in different formats. There is a search bar that can help you with different kind of filters as well. So you see how the portal looks pretty nice, and it can be used as a example of how it would look if you would like to host your own fair data portal for the data publishing pipeline. And with that, we come to the end of today's webinar on the fair data publishing workflow. We thank you all for staying with us and listening to us. We would be very eager to hear your feedback.